Hi, today we will talk about ionic bond. Ionic bond is formed when an atom transfers its electron to the other element. Then they become ions and they will attract to each other. Atoms, when they are released electron, they will form a cation. It's a positive ion. Metals basically have small number of electrons in their outer shells, and also these electrons is cost very small to release it. It's determined by its low ionization energy, so the atoms need to absorb a little energy to release that electron, and this release of electron will achieve a noble gas electron configuration. Group 1, they have one electron in the outer shell. They can lose one electron to form +1 ions. Group 2 will lose 2 electrons to form +2 ions, and group 13, they will lose 3 electrons to form +3 ions. Okay, let's have them in dot cross diagram. Dot cross diagram is a representation of electron from the atoms that being lost, being accepted or gained, and also being used together. So we differentiate the the electron using symbol dot and cross to distinguish which element, which electron is belong to which element, something like that. So for example, here we have sodium. Sodium will have 281 electron configuration. That one electron is the valence electron. To achieve noble gases electron configuration, sodium will release that one electron to form sodium ions. Now the valence electron of sodium is 8, which is because the third shell is empty now, so the valence electron now is the second shell. So second shells have 8 electrons. By doing so, because electron is negatively charged, so missing one electron, sodium will have extra proton. So the overall charge of the atoms now become positive, and the electron is free. And this is the simple equation of that formation of cation. So sodium will form sodium plus electron. Actually, this process is forms from two-step reactions. The first one is atomization, or in some books is called sublimation, because it forms sodium solid to forms sodium gas. Sodium solid forms the metallic lattice, so that's why it's also called atomization. Then if the energy is sufficient, the sodium gas will release one electron. The process is called ionization. But when we add them together, this reaction, so the overall reaction, still sodium solid to form sodium plus gas plus electron. Let's take a look on different kind of cations, which is magnesium. And magnesium has extra 2 electrons in the outer shells. So same as sodium, this electron is being lost and released as a free electron, and then the magnesium itself become +2 ion. The reaction, the simple reaction, is Mg to forms Mg2 plus 2 electron. While in the multiple steps reactions, we have atomization or sublimation of Mg to forms Mg gas from Mg solid. Then the first ionization from magnesium gas to form magnesium plus electron. And also if electron is still sufficient as energy, if energy is still sufficient, it will form second ionization. So it will form magnesium plus to become magnesium 2 plus gas plus electron. So overall reaction is magnesium solid to forms magnesium 2 plus gas plus 2 electrons. Okay, let's take a look at the other part of the ions. The counterpart of cation is called anions. Basically, non-metals, they have many electrons in their outer shells, so it is hard for them to lose the electron. So instead, they will accept or gain more electrons because they have high electron affinity. So there will be much energy to release during this process. Group 15 will gain 3 electrons to form -3 ions. Group 16 will gain 2 electrons to form -2 ions. And group 17 will gain 1 electron to form -1 ions. Okay, now we analyze the dot cross diagram of anion formation from group 17. Take the example fluorine as the example. So fluorine has 2 and 7 configuration. 7 is the outer shell electron or the valence electron. So this fluorine will gain 1 electron. Yeah, if I indicate here with different symbol. For electron from fluorine itself is dot, and the extra electron, the external electron, is cross. So it means that these electrons originally doesn't belong to fluorine. So at the end, it will form the electron in fluorine has an extra. So it means there are extra electron. So the overall charge will be -1. So this is how you draw a -1 anion atau ions. So you put a bracket on it and then put the overall charge at the top. So the overall reaction will be F plus electron to forms F minus. Two-step reactions for this fluorine ion or fluoride ion formation. Atomization, yeah, from F2 to forms F atom. They will separate from diatomic molecules to forms atoms, and then if there is another energy supply, they will forms F minus while they gain electron. So it forms F minus. The name change from fluorine to fluoride. You just change the the ending of the ions from their element to forms fluoride. So fluorine changed to fluoride. And this is the overall reaction. I'll give you another example using oxygen. So oxygen have 6 electrons. So oxygen needs 2 extra electrons to complete as the electron configuration from noble gases. So it will gain 1 electron and another electron here. So it will become oxygen ions, negative ions, with the charge 2 minus, and the name also changed from oxygen to oxide ions. This is the simple reaction of it. So oxygen plus 2 electron to forms oxygen 2 minus. Then it will involve 3-step reaction for this formation of oxide ions. First, the same with fluorine. Yeah, so there will be atomization from oxygen molecule turns into oxygen atoms. Then the first electron affinity, yeah, so oxygen will receive one electron to forms to receive one electron and then to becomes minus. Then the second electron affinity, O minus, will receive another electron to forms O2 minus or oxide ions. Then the overall reaction is half of O2 gas plus 2 electrons to forms O2 minus gas. So now we have cations and anions. What happens if we put them close together? Yeah, they will attract each other because the opposite charge of these ions, they will have electrostatic attraction between them, and this attraction is called or defined as ionic bond. And this also opposite ions is basically forms when the electrons are transferred from one metal atom to the non-metal atom. This electron transfer produce cations and anions, and they will held together by a strong electrostatic forces within a giant ionic lattice. The structure regarding the giant ionic lattice will be discussed in the next video. Okay, this is the example of bonding forms between sodium fluoride. Basically, electron from sodium is being transferred. Yeah, so sodium will lose one electron and fluorine will gain one electron, or the electron is being transferred. So from sodium, the electron is loose and then received by the fluorine ions, fluorine atoms. Now both of them have charge. Sodium become plus, fluorine become negative, or we call it fluoride. And then there will be attraction between two of them. Yeah, this attraction will forms ionic bond. So for the ionic bond, dot cross diagram for ionic bond in natrium or sodium fluoride, just put them together like this. So this is enough for sodium fluoride dot cross diagram. And then we can also draw them, only the valence electron remain. Yeah, so we don't need to draw the electron inside on the inner orbital. Yeah, so just the outer shell electron is enough, because this electron, the outer shell electron, is the one that actually involved in bonding. Okay, what happened in magnesium fluoride? In magnesium fluoride, magnesium will release 2 electrons, while fluorine can only gain 1 electron. So we need 2 fluorine atoms to accept the electron from the magnesium. So one of them goes to the left fluorine, and the second one goes to the second fluorine. So now they become magnesium 2 plus and fluorine minus. So there are 2 fluorine minus. They will attract to each other. Then the ionic bond is formed. So this is the representation or the dot cross diagram of magnesium fluoride. And this is the dot cross diagram when we don't draw the outer electron. So just the inner electron is not being drawn, so just the outer electron or the valence electron. So this will be your practice. Please draw potassium chloride and aluminum chloride KCl and LCl3 dot cross diagram forming an ionic bond. See you on the other slide.